Web 3.0 has the potential to completely change every single industry out there. And one industry in particular where we're seeing lots of new things pop up under the Web 3.0 umbrella is the gaming industry. It's one of the fastest growing sectors of the crypto space, and there's so much opportunity to create an addictive game that people will actually use that offers, some sort of Web 3.0 experience. And that's exactly what you're going to learn how to do today in this video, is how to create a blockchain jumping game like Doodle Jump, like one of these hyper addictive games powered by Web 3.0. So this is an amazing project to learn the fundamentals of blockchain development, how Web 3.0 works, how NFT works, how to create a game, and it's perfect to use for your portfolio if you're trying to land a highly paid Web 3.0 job. And you don't have to be an expert to get started today. We're going to show you everything from scratch. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you have been watching this channel for a while, then I want to introduce you Victor, who's going to help with this tutorial today. He's done a great job of putting this together. He's a complete expert in this topic, and he's going to do an amazing job at showing you how this works. And last but not least, if you like what you see in this video and you want to take the next step, I've helped thousands and thousands of people become real-world blockchain developers, many of which who had zero coding experience before they get started. Just head on over to dappuniversity.com/bootcamp to get started today. All right, enough of that. Let's get started.
Before we start coding, let's see the game that we're going to build. So this is a very simple jumping game where the goal is to score as much as possible and collect NFTs. And later you can mint those NFTs that you got from the blockchain and use them as skins in the game. So we got score 19 and our NFT scores, the NFT that we collected are 6. And now we can connect our wallet and try to mint an NFT. And this is an NFT collection of 10 NFTs. Currently we have unlocked only 1. And this NFT collection is deployed on the Polygon Mumbai testnet. And after we have minted an NFT, you can see now we can use this as a skin in the game. So if I click on the skin and refresh, you can see now I'm using different skin. And of course I can mint another NFT. Let's try this one. We'll wait for the transaction to be mined. And after the NFT is minted, you can see we unlock this NFT that we can select and use in our game. Before we start coding, I'll go over each of the concepts, like what is blockchain, what are NFTs, and how blockchain technology improves the traditional video game. The blockchain is a network of computers all over the world that are talking to one another, and it is also a database that is shared among all the computers on the network. And you can store many things inside of a blockchain, inside the blockchain database. But on most blockchain, the blockchain database is just a record of all the transactions that happened from when the blockchain was first created. And you can even join this blockchain network by running your own node. And within a blockchain, all the data is stored on all of the computers on the network instead of being on a central server on one computer having a single point of failure. So all the computers hold a copy of the data on the blockchain, and that's why it's hard to manipulate this data. And on the blockchain, what you can do is you can create cryptocurrencies and NFTs. And similar to cryptocurrency, NFTs are again stored on the blockchain, but the NFTs are unique. This is what the NFT stands for. NFT stands for a non-fungible token, which means it's not fungible. It means you cannot trade it for something else. And in this video, we'll create our own NFT collection and we'll upload our NFT collection on IPFS. And IPFS is a way to store data in a decentralized way. And this is what most NFT collections use. And lastly, how does the blockchain technology improve the traditional video games? So before blockchain, on any traditional game, whenever you play the game, you will earn in-game items, and these items are stored on a central server. But with blockchain game, they are actually stored on the blockchain itself, which means that you own the items instead of the people who control the central server do. And for our game, we'll create this browser game using HTML, CSS, and JavaScript. But this game talks to an NFT smart contract on the blockchain or our NFT collection to mint these NFTs. So let's finally start creating our game. So first you need to open Visual Studio Code. This is the text editor that we'll use to write our source code. First we'll develop the browser app, and then once we get to the blockchain part, we'll develop an NFT smart contract and deploy it to a public testnet. So just create a new folder on your desktop, click on open folder. So we need to open the empty folder inside here. Inside here, what you want to do is every website needs a HTML. So we'll create an index.html file. Inside here, I can create a boilerplate code with just exclamation mark, and I'll change the title to jumping game. To start our web app, I'll create a new file. This is going to be the CSS for our app. I'll call this styles.css. We want to link this file in here by using the link tag. The relationship is going to be stylesheet. In the href, we need to provide the path, which is just styles.css. For the actual gameplay, we'll use JavaScript, and for this I'll create an index.js file, and I'll link the index.js just before my body ends by using this script tag. And inside here, you want to use the source tag and just say index.js. I'll add a div inside here with the class of container, and this is where all of our game will be. In the CSS file, I'll simply create this container class now, and this container will be basically how long our game will be. So this is the container with this aqua color. The width will be something like 500 pixels. We'll have a height of 700 pixels. You can set whatever background color you like. The position will be relative. We'll have a font size of something like 50 because here we'll write the basic score and the NFT score, and we want to align this text to be in the center. Then I want to go inside my index.js, and I'll dynamically create a player here, and this player will be basically the character. First we'll make it green or whatever color. It will not have a skin. To add a player in here, we want to first take the container because we'll add the player to our container element. So, and we can take this by saying document.query selector, and we can say .container. I'll create the player by saying const player equal to document.create element, and we'll create a div. Then I want to access the container and append a child, which will be my player, and I want to add a class to this player by saying player.classList.add, and we'll call this player, and we haven't created this class yet. So let's go inside our CSS, and this class will specify how our player will look. So it will be a rectangle, so let's give it a width of 50 pixels, and we'll give it a height of 70 pixels, and of course a background color of, let's say, blue. So far, if you were to open this app inside the browser, first actually you need to go inside extension, and if you haven't installed, you need to install the live server extension to be able to see this website inside the browser. And then once that is installed, you can right click on your HTML file and just click on open with live server. And now we can see our player. This is just this blue rectangle and our container div. We need another class, like I'll call this ground. This will be the grounds that the player jumps onto. So let's create this inside our CSS file. I'll call this .ground, and inside here this will have a width of 75 pixels, height of 15 pixels, a background color of green, or you can change this to whatever you like, and you will have the position will be absolute to the container, and it will have a z index of 1. This is because we want the NFT that we'll create later to overlay this ground. This is why we'll add a lower index here, and to the NFT later, when we create the NFT class for our NFT that you can collect, we'll add a greater z index value. So let's move up this player a little bit, and inside our index.js, let's see how we can move the player. So basically we'll have, because this container is positioned like this, we'll just move our player by using the left space horizontally, and we'll have a bottom space variable that we'll use to position him vertically. So let's create this. We'll have player left space. Let's say this is equal to 50, and we'll have player bottom space equal to 150. And instead of creating the player like so, I'll just copy this and create a function, create player, put the code to create the player inside here, and then we want to say create, we want to call this function. And now let's try to move the player with these variables that we created by accessing the player, saying style.bottom, and the bottom will be the player bottom space, plus of course we need to specify this in pixels. And also I'll say player.style.left is equal to our left space variable plus the pixels. And of course for this to work we need to add a position absolute in our player class. So save this, and you can see the player moved. And we're using just two variables to move this player, and we'll use this throughout the game. So that's how you make the player move. Let's now create our ground that our player will hop onto. And we have already created the ground class in CSS. Let's now go into the index.js, and basically we'll just save these grounds inside of an array, and at one time we need to have 5 grounds. Let's create the class ground, and inside here what we want to do, we'll actually create a for loop here that loops through and creates a ground. And how we will create a ground, we'll have a constructor, so whenever you initialize one instance of this ground class, will automatically create and display a ground in the browser. So this we'll need to pass one variable, and this is how much from the bottom will be this ground, and we'll calculate this dynamically inside our for loop. So we'll add a bottom variable to this ground, and we'll just pass whatever we get passed here in the constructor. Then we'll randomly generate our left property by using this math random function. And I'm saying, and this will generate a number between 0 and 1, and we need to times this times the basically the width, how much can we go left from here. And because our game width is 500 pixels, I'm just saying 500 minus the width of the ground, which is 75, and this is equal to 425. And then we need to add the actual visual. This is what will be shown in the browser, and this will be a div. Then I'll just take this visual as a variable because I want to add a class, the class ground that we created in our CSS. Then I'll just say style left and bottom, and I'll just add the left and the bottom to our visual, and I'll append this visual to the container. This is the part where you display this ground in the browser. To create our grounds now, let's declare a new variable, call this ground count. This will be equal to 5, and now we can create a function, create ground. Actually grounds, because this is going to be 5 grounds. So inside here we'll have a for loop that starts from 0 and goes up to the ground count. Inside this for loop, between each of the grounds we'll have a ground gap, which will be 700 divided by the ground count, because 700 is our game height. Then for the bottom, this is the actual bottom of each ground, we'll just calculate this dynamically using this I variable. At first it will be 0 times the ground gap, and it will increase, so each of the grounds is higher than the one previously. This is how this is calculated. And then we can finally initialize this ground by passing this ground bottom, and basically this will create our ground. Then I'll create an isGameOver variable. We'll just use this to see if the game is over, and I'll have a start game variable, function. Inside here we want to call this basically to start the game, and I want to check if the game is not over, and if it's not over I want to create the player. So I'll just delete this here because we don't need to duplicate this, and I'll just call create ground, and of course I'll call start game. So let's see what we've made. Let's go into the browser, and you can see the player is not moving, but you can see our 5 grounds that we have created. If I refresh, you can see it is randomly generated where these grounds are set, and we can change the color so it's not so everything is not green to our ground class, and just say something like red, so we have more contrast. So let's actually kind of simulate that we're moving the grounds. And by the way, in games everything is a simulation. So what we want to do is, inside this start game, we'll invoke this function called setInterval, and basically this will setInterval function, it runs a function, another function, this is the actual function here. We'll actually create this and call this moveGrounds, and this moveGrounds function will be called every 30 milliseconds. Let's create our moveGrounds function, and we don't want to move the grounds all the time, so we want to only move the grounds when the player is somewhere in the middle. So let's put this player in the middle so we can see how our grounds moves. So let's say the bottom space is equal to something like 300, and we want to move the grounds if the player bottom space is more than 200. So if this is true, then we want to move each of the grounds by something like 4 or 5 pixels. So we don't have access currently to all the grounds, so let's create a grounds variable, an array. This will be empty at first, and then we'll just add all the grounds by accessing our grounds array and then saying dot push. And now that we have all the grounds, we can loop through them and just move them, basically increase their bottom space or decrease them because they're going to go downwards. And let's loop through them by saying grounds for each, and this takes in basically an array where a function where the parameter is the element that you are looping through. And inside the function, what I want to do is access this ground. This is, by the way, an object, and we can access the bottom, and we can say something like minus equal to 5, and this will basically loop. This moveGrounds will be called, and each 30 milliseconds, if the player is in the middle, we will we'll move the ground downwards, and each of the grounds. So we set this to -5, but our actual visual will not change. So let's take the visual inside of a variable. We can take this from our ground object and say .visual, and then we can say visual.style.bottom is equal to ground.bottom plus the pixels. So to be able to see this change, we need to make the jump logic of our player. To do this, I'll create uptimer ID and downtimer ID, and these are the functions basically that will trigger our jumping, and we need to save them inside here so we can stop the jumping later. Basically, when you jump, then to a certain point, then the player needs to fall. And I'll do this inside this jump function. And before we start jumping, we need to clear the downtimer ID, which is basically our function to fall, which we haven't called yet. Also, I'll add isJumping variable, and this will be basically indicate whether we are jumping or not. And since we call this jump function, it will be true for now. Then I want to create my uptimer ID, and this is how we create it. Again, we use 30 milliseconds, and every 30 milliseconds we want to basically jump by 20 pixels, and we'll just add this to the visual. Let's create the fall function now. Inside here we'll do something very similar to the jump function. We'll clear the uptimer ID interval, so we stop jumping. Then we'll create our downtimer ID interval. This is equal to setInterval, again 30 milliseconds, and each time we fall we want to decrease this by 5, so we'll fall very slowly, and you can change this to whatever you like to make the game harder. Let's now create the end the game logic or function. What we'll do when we end the game, we'll set the is game over to true. We'll clear the up timer ID and the down timer ID. And when falling, we want to check for the player bottom space and see if he lost the game. And if this is less than or equal to 0, we want to end the game. And just a little add-on here, when we are creating the player, I want to the left space to not be random and to actually use the left space, the left property of the first ground. So when I assign this left property, I will access the first ground by saying grounds 0 dot left. So whenever we are falling, basically whenever this fall function is executed, we want to check if we have landed on a ground. And how can we do this? So in the fall function, what we can do is we can check with a complex if block. And first we need to make sure, actually let me go into the browser. So how can we detect that this player has landed? If his bottom space is basically in between this and this of the ground, then we know that the player is inside here. And if the player left space is somewhere in between here, the left space of the ground, and plus the width of the ground, then we know that the player has landed. And how can we check for this? So if the player bottom space is greater than the ground bottom, and it is also in between the ground bottom plus 15, this is basically how much height is the ground. And also we want to check for the left position. So if the player left space plus its width, which is 50 pixels, is greater than the ground left, and also if the player left space is less than the ground left plus 75. And also we want to check if the player is not jumping. And if this is true, we want to jump again because he has landed on a ground while falling. Now let's see how we can move the player. I'll just create this on key press, and basically this will add an event listener, and whenever you click a button, this will be called with an event, and we can detect which arrow you clicked by just saying if the event.key is equal arrow left. We'll call move left function that we haven't created yet, and the same thing for when you click right. And also because the game has a small width, and because the game has a small width, whenever you come to these edges, basically you will just bounce off. We'll program this, and that's why when you click on arrow up, you would move straight. Basically you would stop moving left or right. And to create this logic, we'll create something similar that we had before. We will have variables that indicate whether you are currently moving left or right. Then we'll have a left timer ID and a right timer ID. These will basically be the functions that move left and right. So I'll create the move left function. And first inside here, we want to check if you are going right. And if you are currently, we want to stop this by clearing the interval. And we haven't created this, but you'll see how we create the left one, and according to this one, we'll similarly create the right timer ID. And inside here, we want to say that is going right is equal to false because we have stopped moving right, and we're actually moving to the left. Then I'll create this left timer ID function. And we'll set this interval again 30 milliseconds. And very similarly in the move right function, I'll create this one here. We'll check if the player is going left, and if it is, we are going to clear the interval, then set this is going left variable to false, and set the is going right variable to true. Then we'll say create our right timer ID to set interval 30 seconds, and we want to check and if the player is on the right side, so basically the game width is 500 minus 50 width of the player, then we will move right by 5 pixels, and that's what we are doing here. Or else, if it's if it's greater than 450, then we'll move left. Basically, if we reach the boundary, the right boundary, we'll just move left. And of course, when we are starting our game, we want to set this event listener by saying document.add event listener, and we're going to listen when you basically press a key, and we're going to call this on key press function. And inside here, I forgot to add the jump function, so when we are starting the game, we want to jump. And currently in the game, there's a little bit of problem, because when we jump, basically the jump goes only to a certain height, and that's why I will create a starting point by saying let starting point, and the player bottom space will be basically this starting point, and I'll have to move the starting point above my bottom space. Inside my jump function, what I want to do is now check right up below my uptimer ID, or actually inside my uptimer ID, I want to check if the player bottom space is greater than the starting point plus 200, and we want to fall. And of course, the most important thing when we are falling, so let me find the fall function. When we are falling, we want to reset the starting point to what is our current bottom space. So we have created the move left and move right function. We need to call them right here. So when we detect that you have clicked left, we'll call move left, and here we want to call the move right function. And we haven't created the move straight function, so let's go ahead and create that. This will be a very simple one. We'll call this actually stop moving, because we're not moving actually, we are stopping the movement. And is going left is going to be equal to false, and also the is going right. Then we'll clear the interval of both the right timer ID and the left timer ID, and we'll just call the stop moving function here. Also, when we are moving the grounds, we want to add a new ground. So whenever one ground reaches less than 10, we want to add a new ground. So inside here, I want to delete this console log, and I'll just say if the ground, not grounds, but the ground dot bottom is less than 10, what we want to do is create a new ground, and I'll call this ground 1. This will be actually, we're not creating new ground, we're just getting the first ground, the visual of our first ground, and we want to remove first the class of our ground. Then I will call the shift method on our grounds array, and this will basically remove this first item from the array. Then I can create a new ground, and remember, whenever I create a new ground in the constructor, it actually gets displayed on in our browser. And then finally we want to push this new ground in our array. And now, instead of actually what I was thinking, instead of creating the player here, I'll just add the player in my HTML. So what I'll do is I'll just go into my index.html, delete this player, and I'll just reference my player that I have by saying document.getElements by class name. And this class name is player. We haven't created this yet. So let's create our div here, and we can create this by just saying .player. This will automatically create a div with the class of player, and we're referencing this player here, and we're doing basically, we can do the exact same thing as we did before. Finally, in my index.html, what I want to do is inside my container, and actually I want to, of course, add this player inside my container. This is my game basically. I'll add two more divs. The first one with an ID of score, the second one with an ID of NFT score. And this one will basically, we haven't created this yet in the index.html, JS, but this will basically show us the score, how many grounds we have passed, and this NFT score is how many NFTs we have collected. And inside here, after you finish the game, you will be presented with these 10 NFTs and for our NFT collection. And first we'll put all of them inside this div with a grid container class that we'll create later. And first this will be hidden, so I'm just adding the class height here. This one doesn't show up, we don't need to add height because they don't have any contents yet. And each of them has a class of grid item. So let's go inside the stars.css and I'll add the grid container class. This is the class that holds all of our NFTs, and each of the NFTs will have a width and height of 100, a background color, and basically this NFT image that we'll put inside our project. And you can add whatever image you like. I just created this random NFT image here. This is a PNG. And of course, we will create actually right now a new file, which we'll call blockchain.js. And this is where we'll put off all of our blockchain logic. Basically, this mint or select function will be the function that gets called on each of the NFTs. And each of these have an ID of from 1 to 10, and we use this ID to mint a specific NFT. And we are passing this element here when we're calling the mint or select function to be able to read the ID and call a function on our smart contract to mint this NFT with an ID of 1 or any one of those up to 10. But we haven't finished yet the contents of our index.js. So let's do that. First, we haven't created an NFT, for example. This NFT class will be very similar to what we have with the ground class. So it will have a constructor, and again the same logic. We will put the new NFT bottom. Here we will pass. The game width is 500 pixel. So 500 minus 75 is 425. Then we'll just we'll create this visual. This will be a div. We'll get this and store inside a variable. Then we'll add the class of NFT, and we haven't created that yet. So let's go ahead and create it. This NFT class will basically have a width and height of 50 pixel. It will be very small. Display will be inline block, so we can change the width and height. The position is absolute, and this is the Z index I was talking about previously. Whenever we spawn an NFT, this will be random, and we want the NFT to overlay the ground. That's why we are setting a higher Z index than the ground. This is what enables us to do the overlay. And the content URL, of course, it would be the nft.png. And I forgot to explain this one, but the grid item one is basically the class of each of the NFTs that show up once you, of the not minted NFTs that show up once you finish the game. And we have a height class that we use on our div, on our grid container div, to hide all the NFTs when we start the game. And let's now create a function that basically checks for collision between you and the NFT, between the player and the NFT. First, what I'll do is save my score inside my NFT score inside the window object, because I'll need to pass this around between my blockchain file and between this current index.js, because in the blockchain file I'll check if you have actual NFT score, and then later you can mint an NFT. And here I'll call this check if collect NFT function, and I will create an NFT array actually, but this time we'll have only one NFT, and we'll inside this array, and we'll move these NFTs but in a very similar way that we did with the grounds. And how can we check for a collision? The same way that we did with the ground. And why is it 50 here? Because that's the height and width of the NFT. And I'll just print out that there is a collision, and I want to increase my NFT score by 1 whenever there is a collision. And what I'll do is I'll remove this NFT because we have collected it. I'll call the shift function. This will remove the NFT from the array. The new NFT will show up on this bottom, and we have already created the NFT class, and this is we are doing this the same way that we did with our ground. And I'll create a couple more functions here, and everything is going to start to make sense. So I'll create a score variable, initialize this to 0. This is basically how many grounds we have moved up. Whenever we are removing a ground, we are increasing this score variable. Inside here, I want to get access to my grid because I'll need to unhide this and show the player the NFTs, the not minted NFTs. I'll get a hold of my score and NFT score element to update this after the game ends. And inside in the game function, we want to do, except these things, we want to do some other things, like we want to clear the interval of the up timer ID, which we have already done. We also want to clear the interval of the right timer ID and the left timer ID. Also, we want to loop through each of the grounds and remove them after the game is over. We want to empty this grounds array. We want to loop through the NFTs array. This NFT array is already starting with one NFT, which is at the bottom space of 500. Then I want to add to my player the class hide that we have defined in our CSS. This will hide the player, so we can only have the NFTs that will show by removing the hide class on our grid. And this is the class that we're going to remove. Then I want to update my score element, and I can do this by accessing the inner text and just saying the score is actually the score you defined here. And we're increasing this score whenever we remove a ground. And also update the NFT score. This is stored inside our window object inside this NFT score variable. And also I'll add this load images of minted NFTs function, and you'll see what this means. This basically loads all the images of the NFTs that you have already minted. And what I want to do is, in the same way that we move the grounds, we want to move the NFTs. So if the player bottom space is greater than 200, we'll just move the NFT, we'll loop through each of the NFTs, and we'll reduce 4. If the NFT bottom is less than 10, we'll add a new NFT, so we always have a new NFT to collect in our game. And of course, for this to work, we need to set the interval, to call this move NFTs with the help of set interval function. And finally, I'll add this load images of minted NFTs function. And what I'll do here is, for each NFT, I'm storing if it is minted or not. So how I'm doing this, I will loop through all the indexes from 1 to 10. And these are basically the token IDs of our NFTs. If this has a value and if it's not null, it means that the element with ID I is minted. So we will just add the image so we can load the image of the minted NFT. So let me now show you the smart contract that we are going to deploy to the Polygon Mumbai testnet. And a testnet is very similar to a real blockchain. This is what we use to test smart contracts. So here, this is basically our NFT collection, and this NFT collection does not store the actual NFTs. We'll upload them to Pinata, and Pinata is basically a service that allows us to upload NFTs to IPFS. And this smart contract will just point to them using this token URI. So let's go over this line by line. So first we will use the OpenZeppelin library or some contracts from the OpenZeppelin library. We'll use the ERC721 URI storage, and this is basically an implementation of the ERC721 NFT standard. And basically we have two main standards of NFTs. The more original one is the ERC721. This standard basically allows us to have one NFT, one unique NFT, and we have another standard that you will hear about, which is the ERC1155. And from this one, you can basically, this is used for like in-game items where you can have like, you don't need to have one sword in the game, but you want to have multiple swords. And this is what this ERC1155 is used for. So we'll use this, we'll just inherit from this smart contract to be able to implement an NFT collection. Then I'm using this counters basically contract to be able to count the token ID. So whenever you mint an NFT, we'll increase the token ID by 1. And this is what we're doing here when we're minting an NFT. And to use this contract, we need to say using counters for counters. This is the contract dot counter. And we'll just declare a token IDs variable of type counter. And inside the constructor, we want to call the ERC721 constructor that we get from this contract. This will initialize our NFT collection, and you need to pass in the name, which is skins, and you need to pass in the symbol of this NFT collection, which is going to be skin. You can call this again whatever you want. So we're not going to have any constructor logic inside this constructor, but we will have a mint function, and this is what you will call when you click on an NFT from our game, and we'll connect to this wallet by using MetaMask. But inside here you need to pass in a token URI, and we get this when we upload our NFTs on IPFS. And this is basically just a URL that points to our NFT, and our NFT is just a JSON file. So let's go ahead and create those. And before we create those, let's see what the mint function holds. So you need to pass in the URL of the NFT or the token URI of the NFT you want to mint, and you'll see an example of this in just a moment when we create the blockchain.js file. This is a public function, which means anyone can call this. And whenever we mint an NFT, we want to increase this token IDs, and we want to call this mint function on the message.sender, which is basically the person that calls this function with this current token ID once we increment it. And this is basically how you can create NFTs. First, you have to have an images for, of course, for your NFTs or for our skins. And what I have created is 10 images here, or 10 skins. You can see we have different ones, and an NFT is basically just a JSON file that points to these images. And here I have another folder called JSON files, and inside here I've labeled them 1 through 10. This is very important because when you click on an NFT to mint NFT, we get the ID of this element, and that's how we are able to mint this JSON file, and that's why I call them through like numbers from 1 to 10. Each NFT is very simple. It has the name. This describes the skin. We have a description. This will show up on OpenSea again, as well as the name. And we'll actually see how you can visualize NFTs on OpenSea once you mint them. And this is the image. So before you upload these JSON files to Pinata, you need to upload the images, because the JSON files reference the images that you have already deployed on Pinata. And how can you do this? You can put all the images. For example, sometimes you have even more than 10 NFTs. So you put them inside of a folder, and to upload them, you need to have an account on Pinata. And after logging in, just click on upload, and we want to upload a folder. Just select the folder, name your folder, and I have already uploaded mine. And once you upload any kind of information on IPFS, you get what is called a content identifier, or CID. And this is the content identifier for my images folder. So I want to copy this, go into Visual Studio Code, and paste this here. And this is how I can reference my images. Basically just using this format of URL, just ipfs.io/ipfs, then paste the folder of your image and say that slash and the name of your image. And this is how I'm referencing all the images. So after you've uploaded your images, created the JSON file, you also need to upload the JSON file, like in the same way like I've done here, in the same way that you uploaded images. And our NFTs are hosted basically on IPFS, and we can use our smart contract to mint these NFTs from IPFS. And actually, to deploy this contract, you need to go inside the deployment section, and you need to, of course, unlock your MetaMask. And your MetaMask should be on the Polygon Mumbai testnet. You want to select here into the contract section, you want to select this skins contract, and inside here we want to deploy using injected Web3. This will allow us to deploy on the Mumbai testnet, use our account instead of the built-in blockchain here. Click on deploy, and MetaMask will pop up and ask you if you really want to deploy this contract. And of course, you need to have a test Ethereum, basically testmatic on the Mumbai testnet that you can get from Faucet, because this will cost money. Not real money, but test cryptocurrency. So after you have deployed the contract in the NFTs and you have hosted the NFTs on IPFS, we can now use ethers.js. This is a library that allows us to interact with the blockchain using JavaScript. So basically, we'll interact with the smart contract and mint our NFTs and create this mint or select function in our blockchain file using this ethers.js library. And we can require this library by just putting this here. This is from the official ethers.js documentation. And we want to, of course, reference this blockchain.js file inside here by saying script source equal to blockchain.js. Inside the index.html, before we mint an NFT, we have to be able to connect to MetaMask, or basically to connect our MetaMask to this Dapp. So I'll add a connect wallet button just under my container, my game, and I'll just, whenever you click this, this connect MetaMask function will be called. So let's create our connect MetaMask function inside the blockchain.js. And this function, what will do, it will use a provider to basically request all the accounts that you have on your MetaMask, and we'll create this provider here by using our ethers object that we got once we imported our ethers.js library. So we'll get this provider, then we can call the send function on the provider. This will basically connect our MetaMask. Then we can get the signer. This is an object of the person that has the account. It has the address and other things like the balance of the signer. And I'll just print out the address. And here I need to define my signer, because I'll use this signer global variable. We need to make this global so we can use this signer to later mint an NFT. So let's create this mint or select function. And if you remember in the index.html, whenever we pass this function, we pass the element that calls this function so we can access its ID. And that's what we have here, just passing this element. And if I access element.id, this will be a string, and this will be the ID of the element that we're clicking. So first we want to check if you have connected your MetaMask, because you cannot interact with the blockchain from this Dapp if you have not connected your MetaMask. Then we want to see if you have the actual NFT score to mint an NFT, and if you don't, we just present an alert and we want to exit out of this function by saying return. Then what I'll do is I'll save the contract address of the contract that we have deployed on the Mumbai testnet, and you can get this by by searching your address of the account that you have deployed the contract with on the Mumbai testnet explorer. So to interact with any contract, you need two things. You need the contract address and the ABI. And the ABI is sort of like an interface of all the functions that you can call. And here you can create the ABI by just creating an array. And this array will have all the functions that you can call. And this is basically the function signature from our smart contract. So if I go up here into my contract, you can see the signature of this mint function. So basically, you just copy this signature and paste it inside here. Once you have those two things and the provider, you can create a skins contract object. And this is a JavaScript object basically created with Ether's library that you can use to call, or basically in our case, mint NFTs. So first, whenever you call this mint or select function, we want to see if the NFT has not been minted yet. And we save data, we save persistent storage in the browser using local storage. And there are three ways. I don't want to get too much into it, but you can save data inside the browser by just local storage or session storage or cookies. And basically it's very easy to set an item inside the local storage. You basically set key value pairs, and to set any of this, you just have to say local storage.set item and just provide the key and the value. And first we check here if the NFT hasn't been minted. How do we do this? Well, for each ID of the NFT, we either store 0 or 1. And if it's null, that means that you haven't stored anything, so this NFT is not minted, so we'll mint the NFT. How we'll do this? We'll call the mint function on this skins contract, and we'll connect the signer, so your account actually calls this function. And remember that this mint function takes in a token URI argument, and this is the URL of the NFT that you deploy to OpenSea. And how can we get this token URI? Well, first you need the CID, the content ID of the folder of all of the NFTs that you deployed from Pinata. And this is again similar or the same format that you had with images up until here. Then you provide the CID but this time of the JSON file and not the images, plus the element ID.json. And this will be 1 or 2 or 0, basically the NFT that you want to mint. And after we call this function, we'll save this inside transaction, then we'll call wait, so we can wait for this transaction to be mined. And once it is mined, we want to now set an item, and this is the key value pair I was talking about. So we are setting the element ID. For example, let's say you're minting the 5th NFT to 1, so this means that it has been minted. And then we want to call the same load images of minted NFTs function. So basically this will load only the NFT that you have called, that you have minted, right after the transaction has been loaded. Or else, for example, let's say the NFT is already minted, then we want to select this and use this as a skin in our game. How can we do this? We can say local storage.set item, and we want to save this inside the current skin key, and we want to save basically the image of the skin. We are not loading them from IPFS, and I'll just input this skins folder in here, and inside this skins folders you have all the images of our NFTs, and this is how you can select these. These are labeled 1 through 10, and basically we'll save the skin that you have selected, and we will load this skin whenever we load this HTML. How can we do this? So if you go to the index.html file, we can have a script. So after we load the player, what we can do is we can take this player by saying get elements by class name. This returns an array, and we have only one element with the class player, so we'll just get the first one. We'll get the current skin, and this is basically the path of the skin that we have selected, and we'll just use this skin and set it as an attribute to my player. And here what we want to do, this was an error that I had. So instead of assigning the grounds, taking the first ground, its left property, and assigning it directly to the player, we want to take the left space of the player and assign it to his, and then you can assign the left space plus the pixels to our player. And also make sure you remove this container.append child, because we have already added the player in our HTML. For our NFT class, we need to also add visual.styleBottom, assign this bottom variable to our visual, and append this to our game. So after we created the function to check for collisions of NFTs, we haven't called this. And we need to call this inside when we are creating the uptimer ID, like so. In the move left, don't forget to add, if you have gone all the way, we should move right. So if I were to test out this game, you can see move left and right works as well. You can click the up arrow to stop moving, and you can see if I were to fall, I get the NFT. If I fall, my bottom property goes to 0, and then you lose the game. So now you get presented this grid of 10 divs or 10 NFTs. And if I click on one, I should get an error message saying that I should connect my MetaMask first. So let's do that. Let's connect my MetaMask. Click on next and connect. You can see after being connected, if I pull up the console, I'm getting printed out my address of my account. You can clear out the console here. And now we have a NFT score of 1. So let's try to mint an NFT. So let's click on this one. It will see that the NFT is not minted from the local storage. And MetaMask will pop up and it will interact with my account to mint an NFT. So if you want, this is how much this will cost. So press on confirm. After the NFT is being minted, you can see we are calling the load minted function function, and this one NFT is being called. So let's now click on this NFT. This will select the NFT. So now if I refresh, a new skin will pop up, and we can of course mint other NFTs if we of course have the score. So if I click on my score, it will say connect MetaMask, and you need to score to mint that NFT. So we got 1, we got 2, and we got 3, and we got 4. And if we were to go to testnet.OpenSea, we can see and connect this, connect our account to OpenSea. You can see the NFTs that we have minted. So we have minted this green and red skin, and I've minted a lot more before when I was doing the testing for this video. So if I go to this NFT, you can see the image that is uploaded on IPFS. You can see the description of the NFT. This is basically the description key that we had in the JSON file and some other information. So that's all I have for you in this video. If you want to learn more and take the next step to become a blockchain master, make sure you visit dappuniversity.com/bootcamp, and thanks for watching.